Hello guys, welcome back to my YouTube channel Part-3 tutorial, and this is the third video of our E3D tutorial series. And today we'll be learning about how to model a vertical vessel or a column in E3D using the PDMS module. So let us begin without wasting any more time. So this is the sample project of Aveva, and I have explained about this in my previous video. So if you haven't watched the part 1 and part 2, then do please watch the part 1 and part 2, and then you can continue with the part 3 so that you understand well about all the basics. And so today we'll be modeling a column. So this is the column which we'll be modeling. I won't be modeling all the nozzles, so I'll just show you some nozzles for you to understand, and the rest of the nozzles you can model by yourself. So let's start. First we have this cylinder of 1413 dia. Okay, before that we have a 2100 square base plate. On that we have a cylinder of 1413 dia. So first let's make the base plate. So I have opened my E3D here, and this is the side zone and everything I have explained in my previous videos. So let me create the equipment. I have to click on the zone, go to the equipment module, make sure there is equipment module here, and click on this equipment tab, then click on equipment. What is the tag of the equipment? Tag is C1101S1. C1101/S1 E3D. Okay, so I'll just keep the origin as 0, description everything you can fill, and I'll click on OK. So my equipment has been created. So as I explained in my previous video, I have to create two sub equipments under this main equipment. So I'll click on this equipment and sub equipment. So, and the name of the equipment, so one sub equipment will be for body, the other will be for the nozzle. So one I'll write it as C1101/S1 underscore body, and OK. And one more sub equipment for nozzle. So C1101/S1 underscore nozzle. So whatever we have the body, like the primitives like cylinder and base plates, we'll create in the body sub equipment, and the nozzles will create in the nozzle sub equipment. So first we have to create the base plate. As today we are using the PDMS module to model this vertical equipment, I have to input a command to start our PDMS module. And in my previous video I have modeled using this E3D graphical method. So if you have any doubts in that, you can watch the part 2 of our E3D tutorial series. So to get the PDMS module, we have to enter the command, that is show gen primitives. Okay, show, then there are two exclamatory marks, then gen primitives. So gen primitives and enter, and you can see that we have got the different primitives here. And if you remember, and if you have worked on PDMS, this is how it looks. So first what we will be using is, we'll use a box, that is for the base plate. And if we see in our drawing, the base plate size is 2100 square. Thickness, I think it is not given, and also I don't want to waste any more time searching for it, so I'll just assume it as 20. So 2100 square and thickness is 20. So X is 2100, Y is also 2100, and Z is 20. And after this, just click on create. And if you see here, our base plate has been created. And next, if you want to rotate the base plate or something, you can use this rotate option. Then if you want to move it a little bit in the east, north and up direction, you can move it from here. For example, if I want to move it in east 50, I can just add it as 50. So I'll just again put it as minus 50 to bring it back to the original position. Okay, or else I'll just enter the 0. I'll just click on next now. So our base plate has been created, and after that, what is there? We have a cylinder of 1403 dia, and the height of the cylinder is 14076. First, let us select cylinder. The dia was 1413. So first diameter 1413, and next the height was given as 14076. 14076, and I'll click on create. You can see that it has taken the center of the cylinder as the origin. So I have to move this point to the base of this plate. So what I can do is, you can see that we have an option like datum. Datum is nothing but the point. Let me just first put it in this one. There are different pick points in each primitives or an equipment. So when you select different points, you can see that our axis is changing at that point. See, point 2 is at the bottom, point 3 is somewhere here, point 4 is somewhere in the center, point 5 is again somewhere there. So what I have to do is, point 2 I have to place it at the base of this plate. After selecting the point 2, you can see here align with P point. So I'll click on this P point, and I'll hold the left click and go over to this base plate and select the bottom point. Okay, so I have to select some other pick point. Yes, now I will pick point here. Yes, so you can see that the cylinder has been moved to the base of this plate. So there are different methods to move it. You can use the by command as explained in the previous video, or you can move it by entering the specific values in up or down so that the cylinder moves. So there are different methods to move. You can select whichever the easiest and the fastest way. Okay, so this is okay. I'll click on next. So our cylinder is ready. I'll just save it. So next we have a cone. Cone, what is the dimensions of the cone? It's 1413 and 1067. Next, I'll select a cone here now. So top diameter. What is the top diameter? This is the top diameter. So 1067. 1067. And next, what is the bottom diameter? Bottom diameter is 1413. 1413. And what is the height? Height, it is given here as 280. So 280, and click on create. It has created at the bottom. So I have to move it to this position. So how will I move it? One method is by using the same datum method, and the other method is, I'll just show you other method. It is by using the position method, like entering the values in the position slots. So first, to move it, I need to measure the distance. So this is resting at the origin. So from here, this point has to be placed on this. So my Z is 14216. So I have to move this cone by 14216. So here again, coming back, I have to move it up in 14216, and I'll just click here. See, my cone has been placed on the top of this cylinder. So if you see in the 3D, it is clear that it is placed. So either you can use this datum method, or you can move it here, or also later on you can move it by using the by command. Okay, so I'll click on next. And next, now we have to create this cylinder. So the cylinder dia is 1067 and height is 7849. So I'll click on cylinder. Height is 7849 and diameter is 1067. I hope I'm right. Yes. So next I'll click on create. You can see that the cylinder has been created somewhere here. I want the cylinder to rest on this top. Let me just show you how to move it by using the by command. So I'll just click on next. See that my cylinder is here. So what is the distance? I have to measure it first by using this tool. So I have explained in my part 2 how to use this measure tool as well. So the total height is, I'll just copy this height, and next I'll select this cylinder, okay, which is that, yes, this is cylinder 1, and I'll go to my command window and type by u and just paste that value and enter. See, cylinder has been moved. So there are three methods as I have shown you. One is by datum, one is by using the position slots, the other is by using the by command method. So whichever is easy for you, you can use that. So finally now we have to create this dish. So the diameter of the dish is 1067 and height is 200. So coming here, where is the dish? Dish is here. So diameter of the dish is 1067, height is 200. This radius, actually this is a knuckle radius, so just for reference I'll enter it as 100 and click on create. It has been created at the bottom, you can see it is here. So I'll just move it using the datum method. So the datum is set at this point, so I'll scroll it down and align with point, pick the point, and you have to go to this top and leave it. Okay, you can see that it has been rotated. So if you want to rotate, you can just use this rotate option here. So around which axis I have to rotate? About y. You can see that our y axis is here, so about that I have to rotate by 180. Apply. Okay, it has rotated, but this datum point is at the corner. I have to change the datum point, so make sure you are selecting the correct datum point. Okay, now it's correct, and again pick the point and place it. See, it has moved. So next, and F11. So you see this, our vertical vessel body has been created. So I'll just put it in the front view. Here it is, and I'll save the work. Yes, and now we have to model the nozzles. So we'll model the nozzles in this sub equipment. So let us see the nozzles now. Here we have like N1, starting from N1. N1 is 100 NB size and 300 rating flange, raised face flange. So N1 is here. From the bottom it is 970. So we have to go to the equipment. Here you can see this nozzle. Here you have to modify the nozzle, and here is to create a nozzle. So let me give the nozzle name. First I'll give the equipment name C1101/S1_N1. So next I'll select the specification. I'll choose the ANSI nozzles. And next, what is the rating? Rating was 300. And size is 100. And height, what is the height? Here you can see 838 is the height from the center. 838 minus the radius will be the height of the nozzle, that is 131.5. So I'll just round it off the values to 130, or you can write the correct value as 131.5 as well, but I will round it to 130. And the temperature, the duty, this data you have to input if you need that, and just click on create. Yes, so let's see where the nozzle has been created. Let me put it in wireframe, and we can see that the nozzle is created here. Next I have to position this nozzle correctly. So first let me look into the front view. Okay, so the 838 is the distance, either in X or Y, whatever. So I'll position this in west as 838. 38. Why? See, in the west I have to move this point, the first point, to 138. Sorry, 838. So here it is. And next, let's see the height of the nozzle. Height of the nozzle is, from the bottom it is 970. So just mention up as 970. Okay, so the position is set. So now I have to rotate the nozzle, so I have to check the orientation. So I'll see in the plan view, here it is. And what is the angle is, you can see here, face of nozzle N1, it's towards the north. Next I want this nozzle to the north direction. So what I'll do is I have to rotate it in the north direction first. So I'll put the angle as 90 above the axis Z. Okay, apply rotation. See, my nozzle has been rotated, so it is Z, correct rotation. Okay, I have to rotate one more time. So again 180. Okay, now it's correct. So but I want this nozzle at this point. So first, after rotating, I have to move it at this point. See, either you can rotate it at the origin and directly move it, or else you have to do a rework like how I'm doing. So better you have to plan it before moving it. So I'll bring it back to the origin. So it is here. So I have to move it in the north direction by 706.5. See, now it is here. So if I see from this view, and I'll put it in the shaded, nozzle has been created and has been positioned properly. So I'll click on next. So N1 has been done. Let us model N2 now. N2 is 250 dia and 300 rating. And where is N2? N2 is at this height, and orientation of N2 is here. Okay, it is offset from the center. Okay, let's do it. So 250 dia. Next N2, I have to write it as C1101/S1_N2. So make sure it is under the selection is on this or on this nozzle. That is, it has to be, selection has to be under this sub equipment of nozzle. So inside nozzle 300 and size is 250, and height is 838. So it is, the height is same, that is 130. We'll keep it as 130 and create. Okay, it has been created. Let's see. Okay, so I'll put it in the plan view. Here it is. So our height of the nozzle is 3611 from the bottom. So let's put 3611 here. 3611. Okay, the height is set, and where it is coming, and the orientation, it has to be towards this side, that is the west direction. On the west, 838. Okay, and next we have to offset it by 380 in the north direction. So 380, I will write it in the north, and let's see in the 3D how it looks. And here, okay, since it is offset, this distance is not sufficient, the length. So let us just increase the length. Let us make it as 250. Okay, 250 is also not sufficient. 500. Okay, you can see that the nozzle has been created. So let us see from the top view. Put it in wireframe, and our N2 nozzle has been created. So you can offset the nozzles by using this position method as well, and just click on next. So our two nozzles has been created. One is N1 and other is N2. So let me make another nozzle. Let us see N3. N3 is here and position is in N3 is similar as to N2, except that we don't need the offset, so I won't model that. So let's model this N7 and N8. Since we have an angle of rotation and these nozzles were just at some 90° or the quadrants, but this is at the angle, so let's do it for this N7. N7 size is 50 and rating is 300. And where is N7? N7 is here, 50 and 300. So I'll just put it, I'll just input the name 1101 slash S1 underscore N7. Okay, and size 300 and size was 50 m. Height, let's see the height. See this, for N9 it has given us 838 and typical for N7, so we will take it as 130 and just click on create, and I'll put it in wireframe now. Okay, let's see in the top view. Here is the nozzle. So how is my orientation? The orientation is towards the northeast direction at 30°. So what I'll do is I'll first set the height of N7 is 1706. So up is 1706, and next it is fixed. I'll rotate it towards the east direction, so it is easy. So apply, and also we'll move it at the distance of 838. Towards east it is 838. You can see that it is coming outside this point, I mean outside the tank, so the datum point is not set properly. Let's pick the first datum point and put this to 0, and now I'll write it as 838. You can see that now the nozzle is at the correct position, so make sure the datum selection is right. I think the same case was with this nozzle, that is why it wasn't intersecting properly. No issues. Then coming back here, our nozzle is created. You can see that the height also has been set properly. The only thing left is I have to rotate the nozzle. So how do I rotate? I cannot use this rotate option here because it will just rotate the axis of the nozzle. See, but I have to rotate it by the axis of this equipment. So what I can do is I'll click on next. Okay, and I'll select this. I'll go to home, and we have a rotation option. Where is the rotation option? Here is the rotate. I have used this command in my second part as well, so I'll use it again here. Advance. What I have to rotate? The current element. How much angle? I have to rotate it by 30. And what is the direction or the axis it is asking? Before setting the axis, just see here, it is rotating with respect to the nozzle. It is same as this, so I have to rotate with respect to this equipment. So I have to write the equipment tag here. So our equipment tag is, I'll just edit it as E3D. So you can see this is the equipment and this is the equipment tag here. So apply by 30. See that now it has rotated with respect to this equipment. So make sure we are rotating with respect to this equipment, that is this center. So I'll just click on apply. Oh, not again, I had already clicked, so one time you have to click. I'll put -30 and apply and close it. Now when I rotate and see, check this, the nozzle has been rotated. So this is one method of rotating. We'll learn other method as well. So we have created 3 nozzles. So I have shown you how to create at the quadrant, offset the nozzle, rotate the nozzle. So now I'll create one nozzle at the top and we'll finish this video. So next, what is this nozzle? The nozzle tag is N5. N5 is at the center on the top. Okay, so N5 I'll create 150 and 300 rating. So I'll write the name of the nozzle, C1101/S1 underscore N5, and size 300 and size is 150. So 150 here. And what is the height? Height we have to check here. 22687 minus this full distance. You can calculate that, but for now I'll just maintain it as 150. Let us assume. Okay, and create. So the nozzle has been created here at the bottom. So first I have to face it to the top. So I'll rotate about which axis? I have to rotate it about y axis. Y by 90. Apply. Okay, so now I have to move it towards the up direction. How much? 22687. 22687, and see that I have moved it to the top, but I think there is a space, so we can increase the height of this nozzle. So let me just increase it to 250. So that is the reason I told you can calculate and write it. I am just assuming 250 is also less, so I'll make it as 350. Okay, fine, this is fine for representation. So next I'll click on this next option, and N5 is also done. So is there any other nozzle which I can model for you? You can also model this manhole, like 450 size, 300 ratings, but I won't be doing that since it is just a similar thing as per the other nozzles, but you can do that. So I can model you this nozzle N12. This will model in a different method. So what I'll do, as I think, and I have shown this method in my previous video as well. So N5, this is N5 which is on the top. Just copy it, paste it. Okay, so I'll rename this nozzle to N12. Remove this and apply. So N12 has been created, but it is at the same center. So but I want it offset by this nozzle by 250 and rotated at 45 degree towards the southeast direction. So 150 I have to move it. So we'll use the command method, that is by, see here, I'll just put it in plan view. Here it is. So I have to move it towards east. Sorry. So by east, sorry, east 250, enter. So here it is, by east 250, and next I have to alter the size as well. So I'll select this nozzle, go to equipment and modify. Here, modify nozzle. Here you can see this tab, then select the size. Let's see what is the size of N12. 50 and 300 rating, so I'll change this to 50. Height, let's see the height. Height is like 206, I guess. So okay, it's not 206, but fine, we'll make it as 206 or just round it off to 200. Our concern is not the dimensions. Our concern here is to learn how to model equipment. Okay, so I'll have to move it down by 206 or 200. So I'll just move it, just make it as 4, just make it as 5. Okay, fine. These things you have to calculate and and have to enter it correctly. Since here I'm just teaching about the modeling, I'm not concerned about the dimension. And now we have to just rotate the nozzle. So next we have to go to the rotate, advanced rotate option. Current element selection is this nozzle. Before this you have to change this to the equipment center. So you have to change with respect to the equipment. You have to write the equipment name here. Okay, and next you can see that the axis has gone to the bottom, and I have to rotate it with respect to u by -45 because it is here. So I'll write it as -45, and first let me see, -45, and apply. See that it has been rotated. Show you here. You can see the nozzle has been created, and we'll see from the isometric view. And there are multiple ways, like I will just give you an example. So this is N1 nozzle. So if you want some nozzles at the same orientation but at different height, I can use copy offset. In what direction? In Z. How much distance? For example 500, and I need 2 copies. Number of copies is 2. Each distance between each is 500. So just click on apply. You can see that 2 nozzles has been created in each distance being 500, and accept. So you can use this method as well, and then you have to just rename the nozzle. Okay, so in the same way you can offset it in the X direction and then rotate Y whatever direction you want, and you can rotate the nozzle to the respective orientation. Okay, so guys, I hope you understood how to model a vertical equipment and also how to model equipment in using the PDMS module. So whichever module you feel is easy, you can use either the PDMS module or the E3D module, which is using this graphical method by selecting the different shapes. And also we have the negative primitives. We will consider this in a separate video for negative primitives and some other important commands. But for now, since this is just for a standard equipment modeling in E3D, as per me this is more than enough. And still, if you have any doubts, do comment in the comment section and I'll clear your doubts hopefully. And I request you to please like this video, subscribe to my channel, share these videos, share my channel with your friends, your colleagues who are learning E3D and also Plan-3D, which I have a separate playlist in my channel. So please share my channel with your friends, and I'll catch you up in the next video. Till then, take care and goodbye.